Test for convergence or divergence. If the series converges, determine whether it does so conditionally or absolutely. If you suspect that a series converges conditionally, then you can skip the alternating series test and just go straight to absolute convergence. So in this, I'm going to test for absolute convergence right away. Look at the sum of 1 over n plus 1 squared. Now this looks like the sum of 1 over n squared. If we ignore all the lower order terms, just go with the highest degree, we get 1 over n squared. So this says try a limit comparison test. So we look at the limit as n goes to infinity of the series that we have, which is 1 over n plus 1 squared, and divide that by the series we're comparing it to, the series we know, which is this 1 over n. So I can rewrite this as the limit n goes to infinity of 1 over n plus 1 squared multiplied by the reciprocal, which is n squared over 1. So this gives us the limit as n goes to infinity of n squared over n plus 1 squared. This is of the form infinity over infinity, so we can use L'Hopital's rule. This gives us the limit as n goes to infinity of the derivative of the numerator, which is 2n, divided by the derivative of the denominator, which is 2n plus 1. This is still of the form infinity over infinity, so we can apply L'Hopital's rule again. This gives us the limit as n goes to infinity of the derivative of the numerator, which is 2n, which is 2, divided by the derivative of the denominator, which is also 2. So this limit gives us 1, which tells us that yes, indeed, these two are equivalent. Since the series on the right converges, it's a p-series with p equals 2, that says that our series also converges. That says that since the series without the sign change converges, that tells us that the original series converges absolutely.